And then they added a combination which has the neutral, and the hot, looking for any kind of series arcing, but you have to have a load, and it works off a higher frequency, and the waveform is different than a parallel, and it doesn't work off the exact same mathematics or the software, whatever it is. It doesn't work the same between the two. Then they also have a neutral to ground sensor sensing, was there a neutral conductor making a connection to the equipment grounding conductor, just like GFCI. We talked about that on the previous DVD. And in addition to that, some of them they're looking for any kind of leakage between the hot wire and the equipment grounding conductor. And that's ground fault protection. And we talked a little bit about this on snow melting equipment, where you're not protecting against persons, you're protecting the equipment against a ground fault. Previously about snow melting equipment, now you have ground fault protection of equipment, and it's GPE, ground fault protection of equipment. Now that, and I think Cutler Hammer has them set for 30 milliamperes. So now you get a breaker. The breaker is listed as an AFCI. It's listed as, with a separate standard, okay, is AFCI. Another standard is a regular multicast circuit breaker. And another standard is, it would have to be listed with another standard having to do with ground fault protection of equipment. So now you have one breaker that would have 3 different standards, and some of these breakers also have GFCI protection instead of ground fault protection. Well, in order to get GFCI protection, AFCI/combination GFCI, it then has to be tested to the GFCI standard. I believe all AFCI breakers have the ability to monitor ground fault current and open under ground fault current, but not all of them, as you said, Kevin, have been tested as a ground fault protector and would have to be specifically tested and be identified. So it gets kind of complicated. I think in about 50 years from now, this is the way circuit breakers are going to be. You're going to have short circuit protection, ground fault protection, overload protection, series arc fault protection, parallel arc fault protection, neutral ground sensing to make sure we don't have any neutral conductors connected to the equipment grounding conductors. And the final one is going to be, what was the last one that was left over? A GF, ground fault protection. No, it's just simply GFCI protection, or at least ground fault protection of equipment. And that's just the way breakers come at one point in our lifetime. Right now you have all these peppered rules in there. Kevin.
In just some anecdotal information, when the introduction of AFCI branch circuit / feeder circuit breakers was introduced approximately 3 years ago, within the first 6 months, I had probably 30 telephone calls from electricians asking about troubleshooting nuisance tripping arc fault circuit interrupters. And in 100% of those cases, the arc fault circuit interrupter worked properly, and it was identifying a neutral to ground connection. So my comment here is that the introduction of the AFCI has probably eliminated a wiring deficiency that has been prevalent for years.
All right, let's take a look at the next slide here. And Eric, you mentioned something about a 15 amp breaker carrying 75 amperes. Well, this is a time current curve. Let's go with a 20 amp breaker. And if you took it 5 times, well, 15 times 5 is 75, but let's just go 20 amperes times 5. So at 5 times, this first line right here is the minimum unlatching time. Okay, and that's the maximum unlatching time. At 5 times, the minimum is 5 seconds, and the maximum unlatching time is going to be 20 seconds. So a 20 amp breaker having 5 times its rating under a fault condition. Now we're talking about RMS, right? We're not talking peak here, under that, which is the peak would be a lot greater than that. 5 to 20 amperes. Let me put this in perspective. If you have a 20 ampere circuit and it's not AFCI protection, and you had a 100 ampere RMS, which the peak of that would be whatever, about 140 amperes peak, it would take 5 to 20 seconds. Can you imagine how much heat, how much energy? The possibility of fire is huge. Now, take the same thing and take a 20 amp AFCI protection device and put 100 amperes RMS. Well, we can't use it because the signature changes. Let's just say go over 75 ampere peak on arcing fault which is a lower level than it would be 100 amperes RMS. So it's a lower level, and it only takes a few waveform characteristics over 75 dB peak before the AFCI. There's no question about it. And AFCI, I've said, well, I don't know if it's going to protect the cords. And I'm probably right about that, because it's not guaranteed to protect the cords, but I'm sure it would protect the cords in many cases. But under the worst case scenario, an AFCI protection device is superior to any other kind of protection device that we have. So I don't want to give the impression I don't embrace the technology, because I think it is a good technology. I just question, I want you to know what it will and will not do. All right, let's go now getting into the rule itself. Now we understand more than we probably want to know about AFCIs. All 15 and 20 ampere 120 volt circuits in specific locations must be protected by a listed AFCI device of the combination type. Combination was the branch circuit. Combination was a series and a parallel. Where do you need AFCI protection? Well, big change in the 2008 code. Family rooms, dining rooms, living rooms, parlors, libraries, dens. It originally was only bedrooms, sunrooms, rec rooms, closets, hallways, similar areas. We're talking a huge expansion. Now, it doesn't apply to the kitchen. It doesn't apply to the bathrooms. It doesn't apply to the laundry room. It doesn't apply to garages. Now, the question comes up is, okay, because kitchens have primarily what? GFCI protection on the countertop receptacles, right? And Steve, you taught us all that what? You have to have two small appliance circuits on those countertop circuits. The laundry receptacles do not have to have GFCI except those that are within 6 feet. Bathrooms do have to have GFCI. All the receptacles in the garage have to be GFCI protected, but the kitchen lights don't. So it's kind of crazy. You got AFCI protection the whole house, but not the kitchen lights, not the bathroom lights, not the laundry lights, not the garage lights, But then the code does say similar areas. So probably the easiest way is to simply do what? Just make sure all the lighting is going to be in the AFCI protected circuit, except the receptacles that are GFCI won't be on the AFCI protected circuit.